Unit 5, Topic 2. In our previous Topic 1, we looked at growth. Well, now we're looking at a decay, which means the numbers are going down. So the first question is a good one. We're talking about cars. It's hard to imagine a new car is purchased, but the person is maybe a little confused. The buyer worries that the car loses a third of its value every year. And let's say the new car was $18,000. They're worried that is the car worth nothing after 3 years because a third plus a third plus a third is a whole. Does a car really lose all of its value? You decide how you want to answer that. We're going to look at the table because we know that car is not going to lose all that value. How do we represent a third of 1800? Well, this is probably going to be my calculator. A third is 1 ABC 3. I'm going to always use that ABC as my fraction button times 1800. That means the car is going to lose $6,000. I don't put 6,000 here. Another way to think about this is if a car loses one third, how much does it hold? How much does it retain? So if I was to take $1 and I take away a third, one minus a third, that means it's going to hold two-thirds of its money. So a different way to think about this, instead of getting 6,000 like we got a second ago, and then I have to minus that number, is I can take the initial number, 1,800, 18,000, sorry, and times it by 2 ABC3. And that tells you, well, hey, that means the car is still worth 12,000. And here's a trick to show you. If I hit it one more time, times 2 ABC3, it'll give me the next answer. It didn't go down 6,000. Now it only went down 4,000. But instead of typing in it every time, once you've done a pattern more than once, you can just hit the equal button and it'll tell you the next number. 5333. Now, if I want to get to 6, let's pay attention. I got to make that would be number 456. So I think the car is worth 1,580. But the truth inside of that is we don't always want to rely on just how many times did I click the button on the calculator. That is why they want us to be able to write an equation. This isn't easy, this is the advanced part, but the idea behind it is this. We know the initial value of that car. It was $18,000. We know that it's going to hold two-thirds of its value, and I can put it to the power of t. And that was why we practiced typing in answers in our previous assignment. So if I wanted to see if I was right on 6, I can try and type that in. 18,000. Notice that it has a parenthesis I have to open. 2 ABC3. You could also hit 2 divided by 3. So like I'm going to show you that I just hit the division button. It'll work. Close your parenthesis. Remember what I called that? The caret. And in this case, I want to just test 6, put a 6 in. It gets you right to that answer. Over here, there's a few good questions. What real life factors contribute to a car losing value? And do all cars lose value? They call that a depreciating asset. Can you think of a counterexample? Prove me wrong. All cars lose value. Is that true? Maybe not. Question 2 is a good question, but we'll talk about that together. Question 3 is another example of this decay. So in NCAA basketball, every year holds a tournament. They want to know how many teams are going to be left. So if every team competes against each other, that means there's going to be one winner and one loser. And that means half the teams have to go home after the first round. So that means now I'm going to take that number, divide by 2. My brain says half of 4 is 2, half of 6 is 3. I can't do that here though. I want to know how many rounds does this ultimately play to get to the end. Ultimately, I want to see a picture. I'm going to do these first few points that I did. Initially, there were how many teams? 64. After one round, there were 32. And then there were 16. Keep that pattern, but then show me the graph. You have to finish it for me. The questions on the back continue. Again, we have an exponential, explosion, versus linear straight line. But notice that our graphs aren't going up, they're going down. So I like to connect the dots and say, if it's straight, we know it's linear. But if we see curvature, we have exponential. Use the same idea over here. There's a few harder questions at the bottom. I believe in you. You can do them. The only other one that I want to remind you of is how to do number 5. If I was to come over here and I'm going to put a 4 in for x, how do I type that in my calculator again? So it says 100 times 3 ABC5, and I have to hit the caret to say the number 4. Now that should look very confusing. Because we used the ABC button, it kept the answer in terms of a fraction. 12 and 24 over 25. At any point, you can say, hey, Gary, I'm not comfortable with that. It says fractions, decimals, but notice it's above. So I hit second PRB, and that will move it to a number that you do feel comfortable with. This answer is also 12.96. That's how you would write it as a fraction. Good luck on the rest of your worksheet.